We introduced LAMVI-2, a system to help developers train and select neural embedding models. A significant number of frameworks allow developers to rapidly build new neural architectures. These make it easy to construct new models, train them with data and hyperparameters, and evaluate the output. When deciding which model to use, different hyperparameters can be tried, and when looking at the space of possible hyperparameters, there are situations where it is easy to determine which is best. However, there are many cases where there is no optimal. Precision is traded off against recall, false against true positives, and model size against performance. We've built a number of prototypes that help developers train neural models. LAMVI-2 was specifically built to address the problem of deciding which models to build and which to use, given different hyperparameters. The interface provides multiple views into the hyperparameters, model details, and performance metrics for many models at the same time. The backbone of the interface is a parallel coordinates plot, which allows the developer to filter models that meet their performance criteria. The view also allows them to find correlations between different input and output variables, detect outliers, and identify portions of the hyperparameter space they have not explored. A second panel provides an embedded view of terms. Given an input query, the interface displays the nearest neighbors of that term. The view is interactive, supporting zoom and panning. The backbone for model inspection of LAMVI-2 is the heat map. Each row of the heat map corresponds to a model, and each column is a word. Given a target word such as plum, LAMVI-2 will identify its nearest neighbors in the embedded space. Each cell is the distance between the anchor and target terms. LAMVI-2 users can directly interact with the evaluation by adding labels. For example, we might decide that a given word pair should be treated as a synonym or antonym. All panels in LAMVI-2 are linked graphically and interactively. Heat map rows and columns can be sorted in a number of different ways to allow the developer to find patterns in the model, clusters of models that perform similarly, or outliers. In our evaluation of LAMVI-2, we found that when comparing debugging steps to model performance, LAMVI-2 performed better at every step. Thank you for watching.